All right, so we're going to look at some growth and decay applications using our general form y is equal to a times b to the x. So our first example tells us that the foundation of an old house has about 1,200 termites. The termites grow at a rate of about 2.4% per day. We want to write an exponential model representing the population of termites. So first thing we want to know is this a growth function or a decay function? So it's telling us right in the problem that we are growing. So this is a growth problem. So that means that when we go to write our b, we need to take our 1 and add our rate. So that's going to be the first thing that I'm going to figure out is, well, what is b? So I know it's a growth, so I'm going to be adding 1 to something. And our rate is 2.4%. But again, I want to write that as a decimal. So that's going to be 0.024 when I move the decimal place over to the left 2 times. So that's telling me that my b value is 1.024. So then I need to know what my a value is. Well, my a value is my initial value, and it's telling us that we're starting off with 1,200 termites. So I'm going to say that my a value is 1,200. So my exponential model, you can use whatever variable you like here. I'm going to use a of t is equal to the a value of 1,200 times the b value of 1.024 raised to, you can put an x here in the exponent, but I'm going to use a t since it's actually giving us a number of days to use in our next part of our problem. So here's my answer for part A. So here's my function. So then what I want to do is I want to use that function to determine how many termites will there actually be after 5 days. So that's telling us that our t value is 5. So if I go to use my function, this is actually asking me to evaluate a of 5 because my t value or my number of days is 5. So I'm going to go ahead and replace every t that's in my function with a 5, and I will calculate that out. So 1,200 times 1.024 raised to the 5th power. And I'm going to go ahead and use some steps just to simplify a little bit. So 1.024 raised to the 5th power. I just used my calculator to get an approximation. So that was about 1.125899. And again, I'm just rounding that to 6 decimal places in here to get a more exact answer. Times 1,200 gave me about 1351.08. But since we're talking about termites, it doesn't make sense to have a fraction of a termite. So I'm going to say about 1,351 termites were in the foundation after 5 days. All right, so let's look at another type of function here, or another example. So trucking company purchases a truck for $80,000. The truck depreciates at a rate of 15% per year. We want to know what is the value of the truck after 6 years. So I'm still going to follow the same format that I followed above. It just didn't break it out into part A and part B for me. So I want to know, first of all, is this a growth function or a decay function? Well, when you see the word depreciates, that means that something is getting smaller. So the truck's value is actually getting smaller at a rate of 15% per year. So this is actually a decay function, which means that when I go to write my b value is going to be written as 1 minus r. So that's going to be the first thing that I calculate here. So my b value is 1 minus r, and my r, or my rate, is 15%. So if I think about the decimal places being after the 15 and move it over to the left twice, that's going to give me a b equal to 1 minus 0.15. So that's going to tell me that my b value is 0.85. So then I need to know, well, what is my a value? Well, the A is the initial or the starting value. So my starting value of my truck was $80,000. So my function here, and again, you can use whatever variables you want, but I'm going to use A of t, is our A value of 80,000 times the B value of 0.85. And again, I'm going to raise that to the t because we're talking in terms of years here. So if I want to know the answer to this question, what is the value of the truck after 6 years? That's actually asking me to calculate A of 6, because that 6 years is representing our t, or our time. So 80,000 times 0.85 raised to the 6th power, because I'm replacing that t with a 6. I'm going to go ahead and evaluate this 0.85 raised to the 6th power. So that's going to tell me to multiply 80,000 by, I'm going to round to 6 decimal places here, so 0.377149. And when I multiply that out by 80,000, that's going to give me 3171.92. And since we are talking in terms of money, because it's asking me what the value of the truck is, I'm going to say after 6 years, I'm going to say the truck has a value of about, I'm going to use money here, so $30,171.92.